Hello again everyone, my name's Mrs Jennison and I'm an Associate Director for Outward Grange Academies Trust. In today's lesson we will be looking at the soluble salts required practical. Our challenge is to be able to describe the procedures to make a soluble salt and select correct reagents. Our aspire is to be able to compare different procedures to make soluble salts. Before we get started, we're just going to do a quick recap of our previous lessons. Can you complete the general word equations below? So first of all, if you react a metal with an acid, you get salt and hydrogen gas produced. If you react an alkali with an acid, you will get salt and also water produced. If you react a metal carbonate and acid, you will get a salt, water and carbon dioxide produced. Now remember, reactions only rearrange atoms. They do not create or destroy them. So if an element is in the products, it will also have to be in the reactants. So when making a soluble salt, the first thing you need to do is choose appropriate reagents. That involves picking the right acid and the right metal insoluble base or soluble base to react it with. So for example, if I want to produce a chloride salt, I'll use hydrochloric acid. If I want to produce copper chloride, I'll probably use copper oxide as my insoluble base. We need you to be able to work out which are the right reagents to choose from for the name of a salt you want to produce. Now, the exact method you use will depend on whether the reagents you choose are soluble or insoluble. So, if you wanted to make potassium sulfate, you could react sulfuric acid and potassium hydroxide. The potassium hydroxide will provide the potassium ions for the salt, and the sulfuric acid will provide the sulfate ions, as shown in the equation below. If you wanted to make copper chloride, you could mix hydrochloric acid and copper oxide. You wouldn't use copper metal because it's not reactive enough to react with hydrochloric acid. Now, I'd like you to have a go at choosing some reagents to make the salts on the screen. You should definitely be able to name the acids. I'll give you a little bit of time and we'll go through the answers at the end. So if I want to make iron chloride, I could react iron oxide with hydrochloric acid. For chromium nitrate, I could react chromium oxide with nitric acid. For sodium sulfate, I could react sodium oxide with sulfuric acid. And for magnesium chloride, I could react magnesium oxide and hydrochloric acid. Now you could have also used a metal hydroxide or carbonate. And for iron and chromium, you could have just used the metal on its own, whereas sodium would be too reactive, so we wouldn't necessarily do that one with the metal on its own. So, the salts that we make, we try to ensure that they are pure. And if we are making a salt, we are making solid crystals of that salt. And they'd look something like this. Those two examples are produced when a solution evaporates. Most salts are soluble in water, so can be obtained by crystallizing a solution. Most bases and carbonates are actually insoluble, which makes it very useful when we are trying to make soluble salts by reacting them with acids. So, when we are making salts from metals or insoluble bases, we use the insoluble reagent by adding it to an acid. Then if we add it in excess, we can then separate out any unreacted solid using filter paper at the end. Now by adding it in excess, we mean we are adding so much that we are left with solid behind at the end. The reason we do this is to ensure that all of the acid is reacted. Metals are also insoluble, so in this, you could use this method for metals also. So the first thing we would do for this reaction is we would warm the sulfuric acid gently to increase the rate of the reaction. Now we don't want to boil the acid, we just want to warm it so it reacts faster. And once we've warmed that, we'll turn off the Bunsen burner. And then we can add copper oxide to that heated acid and stir it. And we continue to add that copper oxide until it's in excess, which means it's no longer dissolving into that acid, which means all of the acid has reacted. Then we'll filter that mixture, and what that does is it removes any unreacted copper oxide, which means we are left with copper sulfate solution. And to get that to become a salt, we'll pour that filtrate into an evaporating basin and heat it on a water bath, at least until the volume of liquid has decreased by half. Then we can transfer that to a watch glass and leave it to crystallise. If we leave it to cool slower, we will actually get bigger crystals. Now, I'm going to insert a video of my colleague performing this investigation so you can see that method in action.
Hello, my name is Mrs. Kershaw, and today we're going to look at the required practical for making soluble salts. This is an acid-base reaction, so for this one we're going to use our sulfuric acid, and for our base in this case we are going to use copper oxide. Now the sulfuric acid and the copper oxide will react to form the salt copper sulfate. But as you will have seen before, copper sulfate is a blue solution that's soluble in water. So in the second part of the practical we will need to remove the salt from the water. First of all then we're going to create our salt, and to do that we are going to need a Bunsen burner. So I have a heat mat, a tripod and a gauze. I have a Bunsen burner, making sure that when I light it on a yellow flame. Right, so first of all, I'm going to take approximately 50 centimetres cubed of sulfuric acid. This isn't a quantitative experiment, so I don't have to be super accurate. see that sulfuric acid is colourless. So first of all, I am going to heat the sulfuric acid. I'm not going to boil it because we don't want fumes of sulfuric acid being produced. And I'm going to heat it on a blue flame. Once you've heated your sulfuric acid, you can then turn off the Bunsen burner. And we are now going to add copper oxide. Now we need to do this until the copper oxide is in excess. And we'll know this because it will stop reacting. I'll give it a stir. So you can see now that we have a blue solution, so we've seen a change in colour, and we still have some of the black copper oxide in the bottom of the beaker. So that tells us that all the sulfuric acid has reacted with the copper oxide. We now need to remove this excess, and we do this by filtering using a filter paper and a funnel. And we see now that we have our blue copper sulfate solution, something you will have seen before, and on our filter paper we still have the black copper oxide that was in excess. Now in this kind of experiment we always add the solid in excess because it's easy to remove by filtration. If we'd added the liquid in excess, then separating two liquids becomes more complicated. So we said at the beginning we were making a soluble salt. So I now have copper sulfate dissolved in water, and I need to remove that water. The way that we're going to do that is by using a water bath and an evaporating basin. So here I just have water that will gently heat this evaporating basin. I'm going to put in some of the copper sulfate solution and then light my Bunsen burner again. We always heat on a blue flame, so I'm going to change it to a roaring flame. Now, one thing to be really careful about in this, and the way that students lose a lot of marks, is they say that they evaporate off all the water, and we don't do that. All we do is we evaporate a little bit of the water to concentrate the solution, and then we leave the solution on the side to crystallise and form copper sulfate crystals. At this point you can see that we've just started to evaporate a little part of the liquid. You can see a little bit round the side of the evaporating basin. That tells us that we've started to concentrate the liquid and some of the water has started to evaporate. So at that point, we remove the gas, take the evaporating basin once it's cooled down and put it on a windowsill to allow it to evaporate over the next couple of days and for crystals to form.
The crystals you would be left behind with at the end of this should be pure copper sulfate crystal. Now what I'd like you to do is I'd like you to answer the questions on the screen. Feel free to pause the video to give yourself plenty of time to answer them. I'd like you to name the 5 stages for making a soluble salt from an insoluble base. Name the other type of reagent. Say what is meant by the term in excess and explain why we use a water bath during crystallization. Okay, so the stages are on the screen now. The other type of reagent is an acid. Excess means that we've added more than enough to completely neutralise the acid. And we use a water bath to gently evaporate off the water without causing the salt to break down. Now, there are common exam questions about salts that come up that can catch you out, and they are often linked to the correct formulae for ions or for salts, and they're often multiple choice questions. There are some simple rules that can help eliminate obviously wrong answers, and you do have your periodic table to help you. By doing that, you can then identify the correct ion. So let's have a look at an example. If the salt is copper oxide and its formula is CuO, what is the correct copper ion? Well, copper is a metal, and metals form positive ions, so you can eliminate 2 already. So it's either Cu plus or Cu2 plus. To figure that out, we can look at the oxide ion. And oxygen's in group 6 of the periodic table, which means it forms a -2 ion. If oxygen forms a -2 oxide ion, that means the copper ion must be 2 plus for the charges to cancel each other out, which leaves us with Cu2 plus. Always remember that a compound will have no overall charge, so you must have the same ratio of positive and negative charges in that compound. Now, there are a couple of rules to help you. Metal ions are always positive. Non-metal ions are always negative. For an element in a numbered group, they will always form the same ions, and the charges are on the screen now. The overall charge of a compound has to be 0, so the positive and negative charges will be equal. And there are a few compound ions that you do need to know about: hydroxide, sulfate, carbonate, nitrate, ammonium, and hydrogen carbonate. These are compounds which have a charge, so they can be involved in these salts. Now, I'd like you to have a go at telling me the correct ion from the salt, and we are looking at the metal ions. Remember, these metals are not from a numbered group, so you need to figure them out using your non-metal. I'll give you a little bit of time, and if you need longer, pause the video to finish off. So let's check your answers. The Cr ion would be Cr3+, because there's 3 negative chloride ions and they have a charge of -1. In iron chloride, the iron would be Fe2+. But in iron oxide, in this example, it is iron 3+, so Fe3+. You may see that they are different charges, but they are both iron, and it's because they're in that central block. So any metal in that central block can form ions of different charges. For cobalt, it will be CO2+, as there are 2 hydroxide ions attached to it. For copper, Cu2O, the charge will be Cu+. But for copper carbonate, CuCO3, the charge will be Cu2+. So that's another example of those transition metals giving ions of different charges. It's time for us to check that we can still remember the method from the start of the lesson. So I'd like you to use what we've done so far to explain how you would prepare a pure dry sample of magnesium nitrate crystals. Remember, when we're explaining how, we need to give a method with justifications. And some things we will also need to include in that method are the reagents we are going to use. So what base will you use and what acid will you use if you are wanting to obtain magnesium nitrate? So it's time to check our answer. The acid you would have used would have been nitric acid, and you'd need to heat that. Add excess magnesium carbonate, or you could have used magnesium oxide, and stir it to ensure that all of the acid has been neutralised. Filter to remove excess magnesium carbonate or the base that you used. Heat your filtrate over a water bath and then leave it to crystallise. You could also pat the crystals down with a dry paper towel. So check you included all of those points in your. And that's everything from me on this video, and I will see you soon.